So today we're going to talk about how to simplify expressions with and without grouping symbols first. Okay, there you go. So before we do all this, we have to kind of do some basic work. You know, sort of a review of what we learned so far. Now, okay. So first we're going to start with a variable. How many people know what a variable is? Well, I think if I ask you this way, which letter do we use the most for a variable? Everybody say it. What? X. We like to use X. So I'm going to define for you a variable. I think a lot of you know what it is. We use variable. Variable is a symbol, isn't it? Symbol to represent one or more numbers. So you're right. We use X a lot. Does it have to be a letter of an alphabet? No, it says it could be it's a symbol, isn't it? So actually, you could use any sort of symbols you like. So I have like heart, star, triangle, and so forth. Okay, so it's nothing more than a variable to represent one or more number. Okay. Oops, it's frozen. Here you go. Sorry. Okay. So go ahead and write it down. I'll wait. So what about an algebraic expression? We need to kind of go over some of these definitions. Anybody know? Somebody give me an example of an expression. Yes, sir. X plus 2, very good. X plus 2 is an expression. Can somebody else? Anyone else? Can someone else give you another? Yes, sir.
X 3 times
2. You mean 3x? 3x times 2? Oh, that'll be 6x. So 6x. Yeah, that's an expression. Very good. So the way we define this is this. But what about this? 5. Is that an expression? We'll answer that right. We'll answer that right after I give you the definition. You guys said no? Let's see. It says, this is how we define it. An algebraic expression is a mathematical phrase that can contain numbers, variables, and operations. Operators. Should be operators. Anyway, operators. Okay? It says that can contain. So does that mean it has to contain all these things? No. Okay, so let's write this down. And I want you to think about that one. Okay? So let me ask that question again. Was it 3 or something? Is 3 or 5? Okay. Is 5 an expression? Looking at this definition? No?
No.
Why not? Why do you say no?
Because it's just a number. It's not.
But it says, look, it says that can contain an ordinary number. Yeah.
Yes,
in the back. Yeah. What did you want to say?
It
It is, you think? Okay, it turns out it is. It is. Because it could be just number alone. I know that a lot of times. Okay, so here's an example. Oh, I'll have it in the. So there are two types. Maybe this is going to clarify. There are two types of expressions. Okay, there are two types. Ones that we're really used to are the ones with variables, right? So expression that contains variable are called. Anybody want to guess? It's called some kind of expression. Expression that has variable in them. Yes. Nice guess. It's a variable expression. Anybody want to guess? Then, so that's one type. One of the type is called variable expression. It's the one with variables, Well, now, if that's one type, guess what the other type is? Yeah. Constant. That's a good guess. So so what do you mean by that? How would that be different than this one? This one has a variable. The other expression then?
Numbers that aren't variables are called constants.
Good. Okay. Good. So the other expression are the expression that do not. So here's some examples for variable expressions, right? You see how you have variables in them, with like numbers, and you got operations, addition, subtraction, multiplication, division, and all that in there. So what do you think we call an expression then? What's then the other type of expression? If you could have expression with variables, what do you think, sir? You could have expression what? Anyone? Yes, sir. Yeah. So why do we call that? Because these are expressions that, they don't have any variables. So expression that does not contain a variable is called numerical expression. So those are two types. Okay. Okay, so here, 2 plus 4, that is a expression, turns out, right? And it turns out that it's called a numerical expression. 5 is is 5, you know, we say, isn't that just a number? Yeah, but you could also call it an expression. Okay, just this one happens to have no variables in it. Does that make sense? Forgot to put a variable expression, a numerical. Anyway, so then let's move on to next thing that we want to talk about. So then what's an equation? They sound pretty similar. Let me move this up for you. Hold on. So we just talked about expressions. Right? There are two types, numerical expression, variable expressions. Then what's an equation? How's that different? They sound sort of similar. Equation, expression, you know, they all start with E, Q. No, the other one is EX. Anyway, they all start with E. Yeah.
Equations have equal signs and expressions don't, right?
Okay, so that's what a lot of people say. Equations have equal signs, expressions do not. What about this? 2x plus 3 equals 2. See, there's an equal sign, right? Is that an expression or equation? Not quite. So you're right. Equation must have equal sign in them, but you have to add something to this. It has to equals to something. It can't just equal to nothing, right? You know what I mean? So I think you got the idea. But here, an equation is formed by, you're right, placing, like you said, an equal sign between two numerical or variable expressions. And so you have both sides, right? So you have sides of an equation. So therefore, you know, you have to have an expression equaling to another expression. That's how you get an equation. Does that make sense? So here, you know, expression equal to another expression. Here, some examples. 2x plus 4 equals to 5. You have a variable expression equal to a numerical expression. You could have 3x plus 5 equals to 7x plus 6. You have variable expression equals to variable expression. Here, look at this one. You have a numerical expression equals to a numerical expression. Is that an equation? 3 equals to 3? Yeah, it's still an equation. I could make it a little bit more interesting. 3 equals to 2 plus 1. How about that? Okay. That's still an equation if you have a numerical expression equal to another numerical expression. What about 3 equals to 5? Is that an equation?
Yeah.
Hey, it is. It's just this equation is wrong, right? What does 3 equal to, guys? 3 equals to 3. It doesn't equal to 5, okay? So but nevertheless, it is an equation. It's just this equation is false all the time, right? 3 is never equal to 5. 3 is always equal to 5. That's why you said constant, right? Somebody said, right? A number is constant. It doesn't change. 3 is always 3. 3 doesn't become 5 all of a sudden, right? That would be bad, right? If it did that. That's fine. Okay, so yeah, you don't really see these sort of equations, but they're nevertheless equations, okay? All right. So what do we do with expressions? And what do we do with the equations? Sometimes people get this sort of confused. And they don't, when they talk about like on your homework or on the test, I'm going to say with expressions, do you think I'm going to say solve equations? I mean solve expressions? Do you think I'll say that? No, can you solve expressions? No, expression does not equal to anything else, right? Expression is by itself. So what do we do with expressions? Does anybody know? On your instruction, it will say, on the test or quizzes, yes, sir. You simplify is correct. Very good. So we simplify expressions, okay? And then what do we do with equations? We then resolve. Well, a lot of times we actually simplify equations then solve, right? But at the end result, I mean, the thing that we want to do at the end is we want you to solve equations. Because equation, it's an expression equal to another expression, and you can solve for one of the variable if there's a variable in there, right? Does that make sense? So keep that in mind. Don't say, oh, let's solve expressions. Okay, that would be the wrong thing to say, okay? There's nothing to solve for when you have an expression because it does not equal to anything else, okay? How many people have heard of substitution principle, or another we actually call substitution property instead of principle? How many people have heard of this before? Okay, good. Not all of you. How many people have heard of, oh, there's a sub in Mr. Huang's class? Right? What does that mean by that? Yeah.
Substitute.
Yeah, someone else is what?
Replacing.
Replacing me, right? Like someone else is here to, right, if I'm out or something. So it's kind of similar to that. So in math, in math, when we say substitution property or principle, anybody want to guess what we mean by that? Yeah.
Solving by substituting.
It could mean that, yeah, if we're talking about equation. But a little bit more, I think you're a little bit ahead of us. It's just basically an expression may be replaced. Just like, somebody could replace me as a substitute. An expression may be replaced by other expression that has same value. Okay, obviously, if they don't have the same value, you can't really replace it, right? So that's what a substitution property is. When you replace an expression with another expression that has the same value, we call that a substitution property. Okay, so this is important, okay, to understand. So I could show you some examples. As you write this down, I'll wait. So somebody tell me, using substitution property, how can I? So is 1 plus 2? First of all, is that an expression? Yes. Okay. Let's use substitution property. Okay. Does anybody know another expression that has same value as 1 plus 2? Yeah. 3. So if I write 1 plus 2 equals to, well, not equal. 1 plus 2 with 3. What property have I just used? Substitution property. Does that make sense? You get that? All right. Can somebody give me another way of? Does it have to be 3? What's another way of writing? Yeah. 7 minus 4 will work. Yeah.
2 plus 1.
2 plus 1. Well, 1 plus 2. Okay, 1 plus 2, 2 plus 1. Okay. Yeah. What about 1.5 plus 1.5? Would that work? Yeah. You could do this all day, right? I mean, how many ways could you do this? Well, infinitely many. You could do this, right? Right. It could be 2.9 plus 0.1. I don't know. You could do this all day. So yeah, when you write it like this, right, you're using substitution property or substitution method. Okay. Substitution property. Okay. Principle. I said principle. Does that make sense? You guys get that? So when you go from 1 plus 2 to 3, or 3 to 2 plus 1, or 2 plus 1 to 1.5 plus 1.5, or 4 minus 1, we're all using substitution method. Substitution not method. Substitution property. Substitution method is something else. Okay, are we good? Now we're finally ready to talk about grouping symbols and kind of what to do with them and so forth. So, can somebody, does anybody know a grouping symbol that we use a lot? What does this look like? Yes, sir. Parentheses. Very good. Is that the only grouping symbol that we could use? No, there are many others. Anybody know another one other than parentheses? It's kind of like parentheses. Yes, sir.
Brackets.
Brackets, sure, brackets. It turns out there are 2 others that we could talk about. Anybody know any other one? So yes, parentheses and brackets are pretty sort of, they're pretty straightforward. Yes, sir. Brace. Brace is used for like sets and so forth, and you don't normally use, for operations. So yeah, not really brace. This one is sort of invisible. You can't really see this one. Turns out there are 2 other ones. So you have parentheses, brackets you already. The third type is, I don't know if you ever thought of this, fraction bar. Fraction bar is a grouping symbol, turns out. Also, you could also add absolute value symbol. When you have absolute value symbol, you have to do that thing inside the absolute value, right? It's sort of a grouping symbol too. Does that make sense? So go ahead and write this down. And what else did I say? Yeah, I used to enclose an expression that should be simplified. What? Anybody know what goes at the end? So grouping symbols are these things that are used to enclose an expression that should be simplified. What? Yeah. Exactly. Simplify first. That's why we have the grouping symbol, right? You got to do that one first. Does that make sense? Okay. Good. Good. So how many people have heard of PEMDAS before? Good. Mr. Bayer calls it GEMDAS, right? Instead of parentheses, grouping, which is kind of fine too. But turns out PEMDAS is sort of misleading. Does anybody know why this is sort of misleading? Yes, sir.
Because for division and multiplication, you have to go left to right.
Exactly. For division and multiplication, you got to go left to right. Okay. As it's written, it looks like you got to do multiplication first, doesn't it? Because m comes first, then d, right? So is that true necessarily? No. What about addition and subtraction? Same thing, right? You got to do whatever comes first, right? So the way I like to write this is I like to do it this way. Sort of a pyramid. It tells you that, like, okay, on top we have the grouping symbol, the parentheses. We have exponents next, and then multiplication and division are on the same level. So they're in the same rank. You can think about it that way. And then so you go from left to right, whatever comes first. And addition and subtraction also, they're on the same sort of level. So you got to go from left to right first. Okay, they're the same sort of operation. Turns out, okay, that's later. Okay, any question? And by the way, what do we call the PEMDAS and so forth? These are not really mathematical terms. Okay, don't. Okay, but what do we call these things? When you simplify expressions, you use PEMDAS. But what is that really talking about? Yeah. That's correct. So that's the correct mathematical term to use. Okay. So PEMDAS is to sort of help us to remember what to do. But we have to use the order of operations. Otherwise, when you simplify expressions, you're not going to get the right answer every time, right? Everyone will get all different answers, right? If you didn't follow the order of operation. Okay. Let's do a simple example. Example 1a. It says 6 times parentheses 5 minus 3. Close parentheses. So obviously, are we going to multiply 6 times 5 first? No. We're going to use order of operation. And we're going to do what first, guys? Class, everybody?
5 minus 3.
There you go. Go ahead. Everybody finish it up and see what you get. So, did you all get 6 times 2, right? Did you all get 12?
Yeah.
Good, easy. Now, this one looks kind of similar to the one on the left. Example 1b, it's got the same 3 numbers, 6, 5, and 3. But do you think you're going to get the same answer here? No, it's because it doesn't have grouping symbol. It does, I don't know, 5, but it's not really. So go ahead, everybody. What should we do first? Can I do 5 minus 3 on this one first? No. What should I do first, sir? Yeah.
2 times 6.
Exactly. I need to multiply 6 times 5. Class, what's 6 times 5? And then minus 3, the answer is? 27. Does that make sense? So just because you have you're using the same numbers, right, doesn't necessarily give you the same answers, does it? Okay. So that's pretty straightforward. Here, this is the one that's sort of invisible. You don't really see a grouping symbol on this one. It's because people got tired of writing the grouping symbol. This really means this. Okay. You should really have parentheses on the numerator and the denominator. So the fraction bar is considered to be a grouping symbol. Does that make sense? It's kind of a shortcut. You should really write it this way, but people got tired of writing it. So, of course, then this becomes 16 over 8. Can I leave it this way? Am I done? No. When you simplify, you have to simplify all the way, right? So, of course, the answer is 2. Easy enough? Okay. Why don't you all try this one yourself? Now, this time you have bracket and a parentheses. By the way, which one do you do first?
Parentheses.
Yeah, the one that is inside, right? The innermost ones first, right? Because I could replace this bracket with the parentheses too if I wanted to. Does that make sense? So which parentheses then do you do? The one that's what? Inside, right? Inside the, okay. Because you'll be looking at that parentheses and you go inside. Okay, go ahead, everybody try. I'll give you time. Shouldn't take you too long. Let's then go over this. Okay, what should I do first here, class? Can I do 18 minus 52 first? Of course not. What are we going to do first, class? 7 plus 6. You get 52 divided by 13 inside. You got to do that in one inside also. How many people got 14? Good. Most of you. All of you, actually. Right? Yeah? Okay, good. All right, let's move on then to another problem. Example 4. This one does not have any parentheses. Okay, it doesn't have any grouping symbol. Just like our objective today, you should be able to do them, simplify expressions with or without grouping symbol. So in this case, what should we do first? Do we add, subtract, multiply, or divide first? We're going to multiply this time first. Isn't that right? So do not do like 5 minus 8 first. You know what I mean? That'd be wrong. So when we do that, what do we get? Somebody tell me what to write next. Yes, sir.
Wait, after 8 times 2.
Yeah.
You get 16 divided by 4.
Oh, so let's just do one step at a time. Let's do 8 times 2, right? Or you could think of this as negative 8 times 2. So you get what? 3 plus 5 minus 16 divided by 4, correct? And then what do we do next here? Divide, yeah. So what's 16 divided by 4, guys?
4.
So what do we write? 3 plus 5 minus 4 or plus 4? Minus 4, yeah. Okay. And you get, of course, 4 at the end. Now, you will find later that I actually like to write things as an addition. Okay? We won't do that right now, but you could think of this as addition this way. And things get a lot simpler. We'll get that later, okay? Any question? Okay. So these are all reviews, right? Here is our example 5. If I said evaluate 4a plus 2b over c minus a, could you do this problem? Not really. What does it mean when I say evaluate? Yes. Put it to the simplest form. That will be simplify. How come I use this word evaluate instead of simplify then? Chris? Yeah, when I say evaluate means I have to actually substitute something in this variable with something, okay, with numbers. So if I just give you a problem like this, you can't do it. What do I have to give you? Yeah. Yeah, exactly. What A and B and C are equal to. Then you could evaluate. Does that make sense? So A is, okay, so evaluate this if A is equal to 4, B is 7, and C is 10. Now we know how to simplify, evaluate this, okay? And so when you evaluate, I'm going to, don't do this yet. I want you to, whenever you evaluate, you're really, basically you're plugging it in, right? When you plug in things, I want you to use parentheses, okay? Please do this, okay? So please use parentheses. What I mean by that is, I want you to write this, okay? See if I could put it all, there you go. I want you to write this, 4 parentheses, 4 times something plus 2 times something, right? Over something minus something. Then I want you to plug it in. Does anybody know reason why, by the way, did any of your math teachers tell you to do this when you evaluate? Okay, good, some of you. Do you know why we want you to do it this way? Yeah.
Because if you use it without the parentheses, it's going to look like 44, 27.
Exactly. If you don't put parentheses, it's going to look like 44 plus 2, you know, what's B? 27, or, you know what I mean? So not only that, when these numbers are negatives and things like that, or if they get a little bit more complicated, it's really easy to make mistakes, right, with negative signs and things like that. And what he said is correct too. You know, if you just write 4, what is that? 44 or 4 times 4? We don't know. Does that make sense? So it's a good idea to, whenever you evaluate or plug in things, use parentheses. And of course, what property are we using? We're using substitution property, aren't we? They're the same value, right? You're plugging in. So go ahead, everybody simplify this now and tell me what you get, okay? So how many people got this when you multiply it out? 16 plus 14 over 6, yeah? What's the answer, class, when you simplify the whole thing?
5.
How many people got 5? Raise your hand. Good? Okay. All right. Okay, any question? So on your homework tonight, it's going to be, you're going to have problems like this to do, okay? And you all wrote down the homework from the board? Okay, so you all get that? Okay. By the way, some of you all have, okay, so do you all have the correct book, right? It's this book right here. Structure and Method, the red one, the small one, not the big one, right? You all have this book? No, this actually. There's one in the back. I'll show it to you. So make sure we all have the same book.